So hey guys, here we have question number 6 from check and understanding exercise of the chapter Optics from the book Pathfinder. So let's look at the question first. Monochromatic light beam is incident on a glass prism, cross section of which is a regular hexagon. Width of the beam is so adjusted that it falls up to middle of two adjacent sides of the prism as shown. For what refractive index of the glass, two separate parallel beams will emerge out. So if you want to give this question a try, you should do it now, and it's pretty simple, so I hope most of you will be able to do it. So now let's look at the hint. The hint is this very simple hint that you have to see by drawing ray diagrams and analyzing that. So if you want to give this again a try, you can do it now. So now let's look at the solution. So first of all, let's try to observe the path of some of the rays. So here I have considered the path of the two extreme rays of incident on each of the faces. So here these dotted green lines are the normals to this face and this face respectively, and so from here, as this is the angle of incident, this is the angle of refraction, and as the glass is denser than the air, it will turn towards the normal. So and we can see that from here this ray could have fallen on this face too, and this ray could have fallen on this face too. So we have to check whether which in which conditions do these fall on separate faces, and in which conditions are we getting a parallel beam finally. So from above, as I've shown, this two extreme rays, if they fall on exactly opposite face after the refraction, we can see by symmetry that we shall get two separate beams. So what I'm saying here is that this line is a normal to the at the surface. So we can, if we construct a line here which is again normal to the surface, we can see that as the both normals will be parallel, this angle will be equal to this angle, and again so hence this angle shall be equal to this angle. So finally the final ray will come out to be parallel to the initial ray. So if the ray falls on this face, from this face falls on this face, it emerges out parallel to the original ray. But if it comes out in somewhere in on this face, we cannot say where it will go. I mean, like, it won't necessarily be parallel to the original ray. So also what we can see that all other rays on this surface will on the same face will fall on the extreme face if it falls on opposite faces. So basically what I'm saying here is that if the extreme rays after the first refraction falls on this face, all the other rays in this region which I have considered in this region will fall on this face, as we can see clearly, and they can't fall on this face because the normal at this point will go through this point, so it will be restricted in this region only. So once we have satisfied the extreme cases, we won't need to satisfy the intermediate cases, in which we'll have to check whether the intermediate ones fall or not. So basically now, as we have gotten an idea, so now let's look at the critical cases in which, and here we can see that clearly in this case when the extreme ray is falling on this face itself, we can see that the two rays are getting separated out. So we are getting two separate parallel beams, as you can see from here. So now let's look at the critical case. So in the critical case, what will happen is that the extreme ray from the upper region will just fall on this vertex, and the extreme ray from the lower region will also fall on this vertex itself. So we'll get two beams, but they will just be separated at this line. So now to find that critical angle, or that critical refractive index of the prism, what we can see is that by Snell's law, mu sin 30 will be equals to mu sin theta, and from here these two lengths are equal, hence these two angles will be theta each, and this angle comes out to be 150 degrees, as by the property of hexagons. You can see it yourself very easily. So from here what we can get is that mu critical will come out to be 2 cos of 15, and substituting the value of cos of 15, we get the value of mu critical to be root 3 plus 1 by root 2. So we got the critical refractive index, and if the refractive index is less than this value, what will happen is that this extreme ray will deviate less comparatively, and will start falling on this face. So we won't get parallel beams in the end. So this refractive index has to be greater than this value, Hence, that's what I've written here. Hence, to get two separate parallel beams, mu has to be greater than the critical value of refractive index. So mu should be greater than root 3 plus 1 by root 2. So that's the final answer, and hope you all like this video. Please like, share and subscribe. Thank you. And also note that some of you were asking for some books or some where to prepare for KVPY and stuff. So I'll be coming up with a blog on KVPY preparations and stuff soon, so you can check it out. Stay tuned for that. Thank you.